Hello, everybody. Welcome back to another video, another lesson. Before we start, I've got a great joke for you. Uh, what, how do trees get onto the internet? They log on. Trees and logs. Okay, man, I hope you guys never get tired of my jokes. So speaking of trees and logs, today we are working on factor trees. That's the lesson. So we're going to figure out what they are, what they do, and how to do it. Okay, so factor tree is basically, it's a way that shows us that most numbers or every number can be written as a multiplication of our prime numbers. Okay, now why we call them factor trees is a factor is another number that divides evenly and very nicely into another number. Now, before we can kind of get through that, and I'll make sure we go through it, I need to make sure you guys understand the difference between prime numbers and composite numbers. So if you could please write these down and I'll show you what I mean. Okay, so we've got these prime numbers and we've got these composite numbers. Now, prime number, hopefully you guys remember is, and if not, it's a refresher. Prime numbers only have factors of one and itself, right? Whereas a composite number, it just means it's basically every other number. So it's a number that's not a prime. So it means it has more than two factors. Now, if you guys are a little bit confused, let's just go through the first 10 numbers. Now, every number kind of works this way, whether they're prime or composite, and we use the same kind of method to figure out which one's which. But just for this example, let's explain using the first 10 numbers. So if we think of one is actually an interesting one because it's actually not a prime or a composite, because one and itself, it's kind of one. But if we think about it, two, how many numbers can divide evenly into two? Well, one works. I can divide two by one, and I can also divide two by two. So technically, this is an interesting one because a lot of people forget two is a prime number because it only has a factor of one. So one can divide nicely, and itself, which is two, can divide nicely into it. Okay, so two is a prime. Now, what about three? So three would be, I can only divide it by one and three, so nicely, so that would be a prime. Now, four can be divided by two. It's an even number, right? So that means four would be a composite, and by that measure, every other even number, 4, 6, 8, 10, they are all composite numbers too, because they can all be divided by two. Right, so that means four can be divided by two, and one and four. So see how there's more than two factors there? Same with six. Six can be divided by one, by two, by three, and by six. So there's four factors there. I don't know if you guys can see my hand. Four factors. Same with eight. One, two, four, eight. So that's four factors. 10 can be divided by one, can be divided by two, can be divided by five, can be divided by 10. Right, so there's four factors there. Now, let's look at the ones that we have left. Let's look at the number. We've done 1, 2, 3, 4. What about 5? 5 can be only divided by one in itself, so it's a prime. 6, we've done. 7 is a prime as well because it can only be divided by 1 and 7. 9 is an interesting one because 9 is odd, but it can be divided by 3. So technically, 9 would go somewhere in there as well. Excuse the noise in the background. I think there's a plane, but I hope that makes sense, that prime numbers can only be divided by one in itself. And so they're normally odd numbers, not every odd number, but they're mostly odd except for two. Okay, so please remember, two is an even number, but it is a prime. It's a special case. Now, when we get to this question here, this is what we're actually going to be doing with it. Now we've got the understanding. What we want to do is we want to make these things called factor trees, and we're also going to try find out how to find the prime factor form. Now, it sounds fancy, but let me show you how that works. So the first thing that you want to do is you want to find factors of whatever number they give you. So here they've given you 50, and I'm just going to draw a little kind of V like that, and I'm going to break it into two numbers I know go nicely into 50. So some of you might say 2 and 25. Some of you might say 5 and 10. It doesn't matter as long as you pick two numbers that multiply to give you 50. So I'm going to pick 5 and 10 because that's a little bit easier for me. Now, once I get to this, I'm going to keep going, and can I break it? I can't break down 5 anymore. So 5 is as far as it can go. So what I'm going to do is, if I can't go any further, if I can't find two whole numbers that divide into 5, I'm going to circle it. But what about 10? Let's see if I can keep going with 10. I know that's going to be 5 and 2. And what's nice about this is, okay, 5 is a prime number, and was 2 a prime number? Yeah, it was. And so that there is how I make a prime factor tree. I break it down into the numbers that multiply and give it the top. Now, what does prime factor form mean? It means that we multiply all those numbers that we've circled, right? The 5, and the 2. So it would be the same thing as 5 times 5 times 2. And we know that that's going to equal to 50 because 5 times 5 is 25 times 2 equals to 50. But we're going to write it like this because we just learned how to write indices. We're not going to write 5 times 5. We're going to write 5 squared, right? Because it's 5 times 5 2 times. And then I'm going to times it by 2. And this is an example of how I made a number like 50, which is a composite number. And I broke it down into its prime numbers. So 5 is a prime, 5 is a prime, and 2 is a prime. Okay, now in case that was a little bit quick, let's try a bigger number where you're like, okay, maybe the numbers might be a little bit harder to see. All right, so let's stick with 108, and I'm going to put it slightly closer to the middle so I can work with it. Now, if you've got a big number and you're thinking, I have no idea what number multiplies into 108, so let's just try, break it into something simple. So 108, I can tell this is an even number because that last digit is an 8. So that means I know immediately, at least I can divide it by 2. So I'm going to put 2 on one side. And on the other side, what's 108 divided by 2? What's half of that? I know it's going to be 54. Okay, now, again, if I'm really stuck and I'm like, oh, I don't really know what two numbers multiply to give me 54. There's a bunch of different options, but even if you're stuck, what you can do is you can go, okay, well, I'm going to halve it again because I can see again, this is an even number. So if it's 54, I know it can be divided by 2. And I'm thinking 2 times what gives me 54? Or what's half of 54? And I can figure out that that's 27. And so now this number is a little bit more manageable. Now it's not even. 27 is not an even number, but I know that 27 is 3 times 9. Right? And then I can't really go any further with 3, but you see with that 9, I know that 9 is the same thing as 3 times 3. And so now I've got all these numbers here. And remember, we're going to circle every prime number. And you have to do that, especially in some of the questions because they ask you to. All right, so 2 is a prime, 54 isn't. 2 is a prime, 27 is not a prime. 3 is a prime, 9 is not prime. 3 is a prime, 3 is a prime. So if I wanted to write this out in prime factor form, and write that down, prime factor form, it's going to be 2 times 2. I see those two 2's, times 3 times 3 times 3. And to write it a little bit nicer using my indices, I'll go 2 to the power of 2 multiply by 3 to the power of 3. And I know that all of that, if you put in your calculator, will give you 108. Hopefully that's right. Yeah, that's crazy. It looks like it's not quite right, but it is correct. And that's how you make a factor tree. And that's how you write it into prime factor form. Hopefully that helps for your exercise. All the best and good luck. All right, see you guys later. Bye-bye.